In this video we will give you summary of Electronics Cookbook, Practical Electronic Recipes with Arduino and Raspberry Pi, by Simon Monk. It starts with introduction like brief overview of the book, its purpose, and audience. Explanation of the cookbook format, practical, step-by-step recipes for electronics projects. Importance of electronics in DIY projects, education, and prototyping. Then things starts as Chapter 1. Basic theory, in which we start understanding voltage, current, and resistance, Ohm's law and its applications. Kirchhoff's laws for circuit analysis. Power calculations and AC/DC basics, calculating electrical power and efficiency. Differences between alternating current, AC, and direct current, DC. Then comes Chapter 2. Resistors, in which we study resistor types and uses fixed and variable resistors, potentiometers. Standard resistor values and color codes. Combining resistors, series and parallel combinations. Voltage dividers for signal adjustments. Then comes Chapter 3. Capacitors and inductors, in which we learn capacitor types and functions, energy storage, filtering, and coupling applications. Reading capacitor values and choosing the right type. Inductors and their applications, using inductors in power supplies and filters. Transformers for voltage conversion. Then comes Chapter 4. Diodes, basics of diodes, rectifier diodes for AC to DC conversion. Zener diodes for voltage regulation. LEDs and special diodes, light emitting diodes, LEDs, and their applications. Schottky diodes for high-speed switching. Then in Chapter 5, transistors and integrated circuits, discussion starts with using transistors as switches and amplifiers, bipolar junction transistors, BJTs, versus field effect transistors, FETs. Interfacing transistors with microcontrollers. Introduction to integrated circuits, ICs, op-amps, logic gates, and microcontrollers. Popular ICs used in DIY electronics. Then comes Chapter 6. Switches and relays, in which mechanical and electronic switches, push buttons, toggle switches, and relays. Solid-state switching for microcontroller projects. Discussed. Then comes Chapter 7-9. Power and batteries, in which power supplies and regulation, designing linear and switching power supplies. Using voltage regulators and batteries. Solar power for electronics, basics of solar panels and battery charging circuits. Discussed. Then comes most important chapters like Chapter 10-12. Arduino, Raspberry Pi, and sensors, in which programming microcontrollers, setting up and using an Arduino or Raspberry Pi. Interfacing sensors and actuators, common sensors, temperature, light, motion. Using sensors with microcontrollers for real-world applications. Is discussed briefly from A to Z. Then comes Chapter 13-15. Motors, displays, and digital ICs, controlling motors, in which DC motors, servos, and stepper motors. Motor drivers and control techniques. Using LED displays and LCD screens, interfacing digital displays with microcontrollers. Multiplexing and advanced display techniques. Discussed in depth. Then comes Chapter 16-19. Analog circuits, audio, and RF analog circuit design, in which filters, oscillators, and signal processing. Building audio projects, amplifiers, sound synthesis, and microphone circuits. RF communication, FM transmitters, radio signals, and wireless modules. Discussed in elaborative way. Then comes Chapter 20-21. Prototyping and tools, building and testing circuits, in which breadboarding, soldering, and PCB design. Using multimeters and oscilloscopes for troubleshooting. Discussed. Then comes conclusion, in which summary of key takeaways from the book. Encouragement to experiment and build real-world projects. Recommended next steps for learning and project developments. After this the book ends.